right, so let's take a look at how do we graph sine and cosine functions. Okay, so before we begin, we're going to have to define a few terms. So a cycle is the shortest repeating portion of a graph. And remember we said a period, right? Sine and cosine and tangent functions, they're periodic, meaning they repeat. Well, in this instance, a period, we're asked to calculate a period when we're graphing. A period is the horizontal length of each cycle. And I'm going to talk about that in the context of this graph. So let's take a look at this first parent function. We'll call it f of x is equal to sine x. They want us to graph it and identify a bunch of things. Okay, period, amplitude, midline, domain, range, x-intercepts, max and min. All right, so over here I already made a table. And the way you graph sine x, right, is just simply plot a few values. Now, the values that you want to plug in are values on your unit circle, right? So if you just take a look at these quadrantal angles, right, at the quadrant, I'm going to plug in 0 radians. So if I ask you what is sine of 0, that's referring to the y value. When it's 0 radians, the y value is just 0. And the next value I'm going to plug in going from, clockwise, or sorry, counterclockwise, right, is pi over 2. And if I ask you what is the sine of pi over 2, you look at your unit circle, right? The sine of pi over 2 is 1, right? The y value is 1. And then so forth, right? You plug in pi radians. If you plug in pi radians, the sine of pi, right? The y value at pi radians is 0. 3 pi over 2 going around the circle. The sine of 3 pi over 2, the y value is -1. And then you go and complete a full circle, right? You plug in 2 pi radians, and the sine of 2 pi, right, is also going to be 0. Okay, so let's take a look at what this graph looks like when we graph it. Okay, so we have 0 radians, pi over 2 radians, pi, 3 pi over 2, and 2 pi. And the maximum y value that we have is 1. The minimum is -1. And so 0, 0, pi over 2, comma 1. At pi, it's going to be 0. At 3 pi over 2, it's -1. And 2 pi is 0. Okay. Okay, so I can also go in this direction, right? I can go negative pi over 2, negative pi, negative 3 pi over 2, right? And then so forth, -2 pi if I wanted to. Okay, so this is the pattern of your sine function, or the graph, I should say. And if you go in this direction, right, it's going to, if you take the sine of negative pi over 2, you're going to be at -1. It's going to hit the axes, go back up to the max, and then go back down, okay, at the axis. Okay, so no reason why I'm drawing dashed lines. I just want to show you 2 periods. Okay, so going back to the definition of a cycle, right? A cycle, if you look here, is the shortest repeating portion of the graph. And I would say 1 cycle would be the distance from here to here, right? That's 1 cycle. Or if I were just to point it out. And actually, to be more specific, right? The period, right, is the horizontal length, right? And so the horizontal length of this 1 cycle before it starts repeating again is just 2 pi, right, -0, which is 2 pi. And so the period of this graph of sine x is 2 pi. And let's just write it out here. The period is 2 pi. That's the horizontal length of a cycle. And again, a cycle is the shortest repeating portion of the graph. And the next term that you have is called the amplitude. What is that? Well, the amplitude, before I define amplitude for you, I'm going to define what the midline is. The midline is basically a horizontal line that cuts this graph in half. And if you were to draw the midline would be right here. It's just the x-axis, right? That's the middle part. So the midline is just y is equal to 0. And the amplitude is the distance from the max to the midline. Okay, so this will call the amplitude, and it's the distance, we'll call it 1. It could also be the distance from the minimum, right? This is called, so this we'll call the maximum. The maximum value is 1. This one right here is the minimum. The minimum is -1. It can also be the distance from the midline to the minimum, in which case the absolute value of A, right, is still going to be +1. Okay, so that's the amplitude. The amplitude is just a value of 1. Again, it's a distance from the max to the midline or from the min to the midline. And later on, I'm going to define it in a different way. Okay, so I want you to see graphically what an amplitude is. You can use, again, either one of those techniques, but keep in mind the amplitude is always positive. Okay, so we got the period, we got the amplitude, we got the midline, which basically cuts our graph in half, right, from the max and min. And of course, we can list out the max. The max and min, just think about it as the y value, right? The maximum y value in this graph is 1. The minimum y value in this graph is -1. And we're also asked to calculate the domain, right? The domain of this function, right? There is no restrictions on x over here, so it's going to be all real, right? And the range of the graph of sine x is from -1 to 1, right? And last but not least, I think we're asked to find the x-intercept. So the x-intercepts, well, the first x-intercept I see that's closest to the origin, right, would just be 0. Because you could start the x-intercepts at -pi, right, -2 pi, right? These are all x-intercepts. But I'm going to pick the closest x-intercept to the origin. In this case, the closest x-intercept would just be 0. And because it repeats, what I'm going to say is x is equal to 0 plus, right, the next x-intercept is right here at pi. Would you agree that these are your first two x-intercepts closest to the origin? Well, if it keeps repeating, right, this is the next x-intercept, you basically just add the distance, right? The distance from 0 to pi is pi. The distance from pi to 2 pi is 2 pi. So I would say 0 plus pi n, where n is an integer, right? Because you can go negative or positive. So if you just wrote x is equal to pi n, where n is an integer, that works as well, okay? So we got the period, the length of the horizontal cycle, we got the amplitude, the midline, max and min, domain and range. So that is the basic analysis of your sine parent function, okay? So the way we graph the cosine function is pretty much the same. And we'll just say part B, we'll analyze it the same way we did in part A with the sine function. So g of x, we'll call it cosine of x. And again, I'm not going to get super fancy. I'm not going to use a graphing calculator or anything or Desmos. All I'm going to do is just plug in those values on the unit circle. Okay, so there is 0, pi over 2, 3 pi over 2, and 2 pi. Okay, so if you remember, right, the cosine represents the x value. So when you plug in cosine of 0, going back to our unit circle, right, cosine of 0, the x value is at 1. Okay, cosine of pi over 2, the x value is going to be 0. Okay, I think I missed the value over here. Let's plug in pi. The cosine of pi, right, when it's at pi radians, the x value is -1. So you kind of squeeze in that pi comma -1. At 3 pi over 2, right, you're going to go back down to 0. The x value is 0. And then last but not least, you go back to cosine of 2 pi. The x value when it's at 2 pi radians, of course, is just 1. Okay, so you can graph this as well. Okay, so 0, pi over 2, that pi value that I missed, 3 pi over 2, and 2 pi. The maximum y value is 1, the minimum y value is -1. And then, of course, you can go in the negative x-axis as well, right? Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay. All right, so at 0, 1 is my first coordinate, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi, I'm at 1. Okay, so this would be the one period, right? This will be one cycle of my cosine graph. One cycle, that's the shortest part of this graph before it starts repeating, right? Because if you were to sketch in the negative x direction, again, there's no particular reason why I'm drawing the this portion of the graph in dashed lines. I just wanted to show you that it's slightly different, okay, from what I just graphed. Okay, so again, this graph just kind of repeats itself, going the oh, I'm sorry, I kind of made a mistake over here. Let me change this graph here. Let me erase here. Okay, so okay, at negative pi over 2, right, it's going to be at 0. Negative 1 is going to be at at negative pi, it's going to be at negative 1, and then 3 pi over 2, it's going to hit the axis, and then negative 2 pi, it's going to go up. So you can just make that adjustment here. Okay, so you can see, right, that this dashed line and this solid line graph basically just repeats, okay? So it just goes on forever in the x-axis, x and y-axis, as x approaches minus infinity, as x approaches positive infinity. Okay, so hopefully you agree that this portion of the graph, right, on the right, which is solid, and this portion of the graph on the left side, which is dashed, right, they're identical, right? And so the shortest repeating part of the graph is one cycle, and the length, right, the period is the horizontal length of this, is just 2 pi, right, minus 0, right? The distance from here to here is one period, right, because that's the definition of a period. And if you just keep going, right, this is also one period, right? And so in your homework, right, it's going to say sketch 2 periods. Well, right now this is one period. If you were to sketch the entire thing, which I did over here, right, this would be considered 2 periods, okay? But this is just one period. This is one period or one cycle. And let's fill in the remaining part of what this graph or what this problem is asking us to find. The period is 2 pi. The amplitude, again, is the distance. You can think of it as the distance. Oops, I spelled amplitude wrong here. Okay, there we go. Amplitude. The distance from the max, right, which is right here, the max value is going to be 1, and the midline, okay? So the midline, again, is the line, the horizontal line that cuts this graph in half. So the midline is still going to be y is equal to 0. Okay, so you can write that out here. Midline is y is equal to 0. And the amplitude is the distance, right, from here to here, from the max to the midline, and the amplitude in this case. Why do we draw absolute value? Because distance is positive. The amplitude is just 1. What else do we have? We're also asked to identify min and max, right? The min and max is not going to change from your cosine to your sine, or from your sine to your cosine. The minimum value, right, of course, is at this point right here, at pi comma negative 1. It's always the y value. So this is your min. Your min is negative 1. Your max is positive 1. The domain of this graph is not going to change. It's going to be all real, right? You can input any x value, and the range is going to be negative 1 to 1 brackets, okay, interval notation. Okay, what about the x-intercepts? The x-intercepts, again, I would pick the closest x-intercept to the x-axis. The first x-intercept I see that's closest to the x-axis, that is positive, okay, I must say it's positive, is pi over 2, right? There's your first x-intercept that's closest to the origin that's positive. The next x-intercept is 3 pi over 2, right? And then, of course, it goes on forever. So what you want to do to write the x-intercept is x is equal to pi over 2. And then what's the distance between 3 pi over 2 minus pi over 2. Well, the distance between 3 pi over 2 and pi over 2, right, is 3 pi over 2 minus pi over 2, which is 2 pi over 2, which is just pi. So x is equal to pi over 2 plus pi n, okay, where n is an integer. So you don't have to write n as an integer, on a quiz or test or homework. That's usually implied when in mathematical notation, when textbooks write n, they typically define that n is an integer, especially for trig functions if it repeats. Okay, so we got period, we got amplitude, we got domain and range, midline, min, and max, and we got the x-intercepts. And how's cosine and sine different, right? Hopefully you can see if you study this sine graph versus this cosine graph, right, is that your cosine graph is basically your sine graph, right? It's almost the same graph, except it's shifted pi over 2 to the left, okay? So cosine is your sine shifted pi over 2 to the left. Okay, now, speaking of shifting, right, like, are we just going to be graphing the parent function sine, cosine? No, it's important that you know what the parent function sine and cosine look like, right? But in your homework, you're going to be graphing with, various numbers, or in other words, transformed graphs of sine and cosine. Okay, so let me give you the general form for sine and cosine. So one of the general forms that you'll have is, we'll say f of x is equal to a cosine of b x minus h parentheses plus k, or if it's called a sine graph, we'll call it a sine b x minus h parentheses plus k. All right, so let me give you some definitions. Okay, so you already know that the a is the amplitude, right? A is called the amplitude. So just reading from an equation, whatever this number is out here, that's your amplitude. So, in the beginning, I defined the amplitude with you by looking at the graph, right? Distance from the max to the midline, or the distance from the midline to the min, right? And the amplitude is always positive. But you can also look, right? Just reading this equation, g of x is equal to cosine x. The amplitude, right, is just this number out here. In this case, the amplitude is just 1. So you could just read it from the equation if you look at, given an equation, okay? But I needed to explain to you graphically what the amplitude is. Now, another way of calculating the amplitude, right, is the distance, right? Of course, the distance between the max and the midline in your cosine and your sine is just 1, right? Another way of calculating the amplitude, because let's say your max and your min were not 1 and negative 1, right? And your midline's not 0, because you're going to have some kind of vertical shift. Well, the amplitude is also defined as 1/2 max minus min. Okay, so it's also defined as 1/2 the absolute value of your max minus your min. Okay, so you can also use that, right? So over here, if I were to say, hey, calculate the amplitude, the amplitude is equal to 1/2, right? The max, which is 1, minus your min, right? 1/2 times 2, you're going to get 1, okay? So you can also use this equation right here, 1/2 max minus min. Okay, so the A is the amplitude, also known as your vertical shrink and your stretch factor, okay? So you have to make that connection from transformations, except in the context of sine and cosine graphs, they call it an amplitude instead of vertical shrink or stretch factor, okay? All right, now, your B, right, is your horizontal shrink or stretch factor, okay? So just, remember that, hey, if 0 is between B and 1, it's a horizontal stretch, right, by factor of 1 over B, right? And of course, if the absolute value of B, I should say, is greater than 1, horizontal shrink by factor, I'm going to abbreviate here, of also 1 over b. Okay, so that doesn't change from what you learned from transformations in the past. Okay, now h is a term, right? It's also your horizontal shift. Okay, but actually in the context of sine and cosine graphs, they call it a phase shift. Okay, just different vocabulary, but it's the same thing as a horizontal shift. Okay, but they call it a phase shift. And of course, your k is your vertical shift, which you learned from transformation. But your k is also your midline. Okay, so your midline is actually equal to k. Okay, or in other words, it's y is equal to k. And the way you calculate your midline is 1/2 max plus min. Okay, max plus min. That's your midline. And, if you were to go back and calculate this, right, if I say, hey, what is the midline? Of course, the midline is y is equal to 0. You could also use this equation, 1/2 max, right, 1/2, 1 minus -1. Sorry, 1/2 plus -1. And you're going to get 1/2 of 0, which is, of course, just 0. Okay, so that's the equation, 1/2 max plus min. That will give you your midline. And I think that's pretty much it. Oh, one other thing is, of course, the period, right? The period is not always going to be, it's not always going to be 2 pi, okay? It's not always going to be the horizontal. The definition is still going to stay the same, but there's an equation for the period, which I almost forgot, is basically 2 pi over the absolute value of b. Okay, so this is important. Because you might be given an equation and you're asked to find the period. And of course, you could just use this formula. It's your 2 pi radians divided by b, which is your horizontal shrink or stretch factor. So 2 pi over b is your period. Okay, one other thing I want to mention before I conclude the parent function explanation. Your textbook, I think, or some other, books might use this. They say, hey, y is equal to a, cosine, bx minus c, right, plus d. Okay, so hopefully you can see that, hey, a is the amplitude. Now, if I ask you what is the phase shift in this problem, right? That you're going to actually have to do some calculation. The phase shift is not c. The phase shift, right? So to what value do I shift the graph horizontally? You have to do a little bit of factoring. Okay, so over here, if I factor out the b, I'm going to have x minus c over b. Okay, and so in this case, the phase shift would just be c over b, right? And then of course your midline, right, is just y is equal to this last number, y is equal to d, and the period is still going to be that formula, 2 pi over b, okay? So depending on what your, what values that your textbook gives you, it always comes back to these basic general forms right here, okay? So the most important thing for you to remember, obviously, is your period, which is 2 pi over b. The amplitude, sometimes from the graph, you could just calculate 1/2 max minus min. Of course, the midline is the line that cuts through the graph at the middle. It's a horizontal line, and the equation is 1/2 max plus min. And of course, you already know some of this from transformations, but as it connects to trig, just be aware that a phase shift is no longer called a horizontal shift, right? They call a horizontal shift a phase shift in trig. Okay, so lots to absorb. Hopefully you're able to get most of that. If not, you're always welcome to ask, and I'll clarify